Hey, this is Devin with Alpha Sound. Today we're going to be testing the NEXO S118 and the NEXO L18. Obviously the NEXO S118 is a much older cabinet, 2012, went with the STM series. The L18 was recently released with the P series, and it's a lot less expensive. These are obviously two of the greatest single 18-inch subwoofer cabinets in the industry, so we're just going to test them out and see how they compare to each other. Today I'm using the 3DO binaural microphone to try to give you the most accurate bass experience I can in a video on the internet. Don't listen to it with your iPhone and think, oh, these subs are weak. Don't be that person. At least wear good studio headphones or listen to it with studio monitors and a subwoofer. Okay, so the first thing we're going to do is collect the general frequency response of both subwoofers, starting with the S118 on the left. I have the crossovers of the subs set to 120, and the test microphone is about 1 meter away. I am sending a moderate level input, so there's no protection or anything kicking in yet. We're just cruising. Okay, so that's the S118, and I'm going to add in an electrical output reading of the amplifier itself. So there in the yellow, you can see the processed signal going out to the subwoofer as compared with the acoustic output picked up by the microphone. Okay, so I've moved the microphone in front of the L18 now, and you can see its trace in white on top of the yellow S118 trace. And both have this bump around 36 hertz here. That's probably just the tuning frequency of their ports. And then the L18 has a pretty smooth ride through the 50 and 60 hertz area, whereas the S118 has a little more of a carved section. We're talking like a decibel or two, though. The L18 has a little bit of a dip around 85 hertz, couple of decibels, whereas the S118 is a little bit more smooth. And then both are high pass and low pass pretty sharply. The filters are very steep. And then, of course, there in white is the L18 acoustic response as compared with the yellow electrical output from the amp. So that's the EQ curve that they've applied to the processing for the L18. Now, going back to the S118, I've put microphones in front of the top and bottom ports. The top port is represented in white, and the bottom port is in yellow, as compared with the purple trace, which is the saved measurement from the total acoustic response. Now, if we add in the phase plot, we can see that it's really hard to understand what's going on. I'm going to actually add a delay to the reference signal so that we can see something in the graph that helps us understand things a little bit better. With the added delay, you can see that the phase relationship of the two ports below the tuning frequency of about 36 hertz, they're out of polarity with each other, and then above the tuning frequency they flip to become in phase. Specifically, the lower port is the one that flips to become in phase. And they are in phase all the way up until just above 100 hertz, where obviously they begin to diverge again, and that's probably where you'd want to cross over, which is what they do. So between about maybe 30, pushing 30 hertz somewhere in there to 120 hertz or so is the usable range of this box. And here's a look at the L18 upper and lower ports as compared with the total acoustic output. And then with the phase plot, again, we can see very typically that below the tuning frequency, the two ports are out of phase, and then the lower port flips to become in phase, and then once again, above about 120, it starts to diverge enough we'd want to cross it over, which is what they do. Another way to look at this is to change this graph so that the reference is the top port microphone, and the mic that's being tested is the bottom port microphone. So you can see, obviously in relation, the bottom port has an immense amount of amplitudinal difference at the tuning frequency and very little at the upper ranges. And you can see the phase flip very clearly around the tuning frequency to being in phase and then drifting out of phase above 120 hertz. Here's that same view for the L18. Now, as a point of interest, this is pink noise being played through the S118 flat with its frequency response as picked up by the microphone. And here is the L18. So next I thought we could just listen to the sounds of these boxes. Not going to push it too hard for now so we don't have to deal with any protection issues or stuff like that. We'll get to that later. but just for now assessing the overall tone of the different boxes, starting with the S118. Switching to the L18. Switching back to the S118. Back to the L18. I think that the S118 has a little bit more punch, maybe, just a little bit more clarity in that sort of upper mid-bass area, whereas the L18 seems to have a more round tone. Now let's listen to a different cut of music. Again, S118 to start with. Switching to the L18. S118. L18. So yeah, to me the L18 sounds a little more round. The S118 has a little bit more punch, but the S118 has more artifacts from wind noise, I hear. So, you know, like the chuffing and stuff of the ports. And this becomes even more apparent when we start to push them a little bit harder, which we'll do now. So I'm going to go back to the first cut, and I'm going to turn the volume up basically as loud as they'll go. So this is maximum input to the amplifier before clipping, and we'll just see what happens. So, S118. You can hear that protection start to kick in and lower the volume. Okay, let's go over to the L18. I'm not really hearing any protection kick in per se, not in the way it did for the S118 by just lowering the volume overall. Let's switch back to the S118 right now. Yeah, you can really hear that volume reduction. Back to the L18. There is some dynamic compression going on there, I can hear it. Let's switch tracks. Back to the S118. Yeah, really drastic volume reduction once the protection hits in. Now, I am pushing these subs for all they're worth. Okay, so yeah, it just stays down there. Okay, so let's go to the L18. Yeah, I'm not really experiencing any like lowering of volume globally. Maybe a few dB, it's hard to tell. Back to the S118. A lot more chuffing and air noise, but punchier. And there's that reduction in volume, very drastic. Back to the L18. All right, going back to the S118 with the pink noise, I want to look at what the protection is actually doing from a frequency standpoint. Are we doing some frequency shading? You know, are we multiband compressing? Like, what are we doing? So let's go ahead and turn up the volume. What you'll notice is that at some point the amplifier will begin to limit the input signal. I'm not clipping the amp, but it's starting to say, hey, whoa, there's way too much. So while the graph will go down at that point, it does not reduce the volume of the speaker, but then eventually the protection will kick in and you will then see the graph go down further with an actual reduction in the volume of the speaker. Okay, and then running the same test for the L18. Now the thing is, I don't really see any general change in the tone or frequency response. There just seems to be a global volume reduction for both subwoofers, the S118 much more so. And if there were quick transients being taken out with dynamic EQs and stuff, this is a pretty slow average, so we're probably not going to see it show up here. Alright, so the next test I want to run is with some sine waves, starting with the S118 at 30 Hz. This tone represents the maximum volume before the protection starts to kick in, at least at this frequency. So what I'm going to do is, again, open it up all the way to just before clipping the input of the amp, and we'll just see what the protection does with it. Interesting, so there was obviously a very loud burst at the beginning. It definitely let a couple of cycles through. And then there was a bunch of distortion sounding stuff and pumping and this sort of thing. And it reduced the volume to a clean sine wave, more or less, at a much lower volume, which is where it obviously will sit until we stop, let it relax a little bit, and then hit it again. So that's that. Let's switch over to the L18. I'll reduce the volume again. Okay. There's the maximum amount before any protection seems to kick in. And let's go ahead and open it up. Okay, interesting. So again, there was a couple of cycles that got through and then some distortion, and then the protection kicks in. Doesn't lower it as much as the S118, but it does introduce some amount of distortion. So even at just a running level here with the protection, there is some distortion at 30 Hz, although it is louder perceivably. Let's let it relax. See what happens. So the protection kicks in a lot sooner than the S118. It just doesn't reduce it nearly as much. Okay, so now I've taken the graph and extended the time out to almost 10 seconds here, And I'm going to hit the S118 again with the 30 Hertz, and we'll be able to see the overall shape of the envelope of the protection until it gets to its resting point. Okay, there it is. So you can see a very, very large amount of transient let through at the very beginning. So if we zoom in, you can see that these first couple of transients get through, and very quickly the protection kicks in, although the protection kind of does this goofy thing. It doesn't sound very natural, but this is a very extreme test. Okay, next, let's do the L18. Very different. So you can see that we have our transient, and then it allows it to stay loud, but it actually kind of has this swell, and then it very quickly reduces it, and it rides on from there. So again, we have the first couple of transients get through all right, and then we have the protection kick in. The protection seems to add some distortion, which eventually goes away when it really protects it. Now the next thing I want to show you is the acoustic output in white compared with the electrical output in yellow. Now the white trace is slightly behind the yellow trace. Part of that is just the fact that the microphone itself is a couple of feet away. So what I'm going to do is change the triggering here so that the triggering for each is just based on its own self, and bring them into alignment visually. Okay, so now I'm gonna turn up the S118, and we'll see if that distortion is in the actual output or just from the box acoustically. Okay, so the distortion seems to just come from the box when it's being driven that hard. Although some of that pumping noise does actually come from the output of the amp. The processing must just be doing something that at 30 Hertz, the timing is just right, that there is some kind of pumping action. Alright, and now the same test for the L18. Again, no distortion on the electrical output, but a much cleaner transition to the protection, and it does sustain a little bit more volume, but the resultant output is distorted. I think just at 30 Hertz, the L18 just, produces a little bit of distortion for some reason. Going back to the S118, let's try 36 Hertz. And here's the L18. S118 at 50 Hertz. Interesting, so at that frequency, it doesn't seem to do the volume reduction for the protection. And the L18. Doesn't do it either. Interesting. S118 at 80 Hertz. L18 at 80 Hertz. So going back to the S118, I'm running a single cycle of 30 Hertz through the cabinet, which you can see on the oscilloscope. Now, if we look at the microphone measurement, wow, we can see that Obviously there's some amount of delay because of the processing and the fact that the microphone is a couple feet away, but there's a lot more going on here. That's very interesting. So let's compare it to what the amp is actually telling the speaker to do. Okay, so in purple is the actual amplifier output, and it looks like the yellow acoustic response is tracking very, very closely. So a lot of this is just coming out of the processor and the amp itself. Now, I don't know why this is. Maybe it's because of all the steep filtering that's going on, and you know, maybe some of it is actually intentional. There's a sort of a textural choice here that's being made that contributes to the sound of the box. Of course, let's see what happens when we turn it up significantly. The window will resize automatically. So you can see that it's just rejecting further input signal after a while and just holding the acoustic output steady. I don't know that, given there's so much space in between each hit, that the protection will actually kick in. If it were a sustained note, it would, as we saw earlier, but I think this is just where it'll live. The L18 looks about the same, and we'll run the same test. Let's increase the volume. I brought the volume back down just for a second here to talk about this. I'm probably showing my ignorance on this topic, but it is interesting that like the acoustic output is a little bit ahead of the electric output at the tailing end here. I don't know why that is. Probably somebody knows why that is, and they'll tell me in the comments. Here is the S118 at 50 Hertz. And let's go ahead and bring up the volume significantly. And here's the L18 at 50 Hertz. S118, 80 Hertz. L18 at 80 Hertz. So going back to the S118, what I've done now is I've taken the amplifier and put it into the flat mode. So this is at 30 Hertz, and you can see that the white trace is the amplifier output, and the yellow trace is the microphone. And obviously, the speaker just adds extra cycles that aren't in the signal coming to it electrically. Now, I think that this here is due to the fact that it's a bass reflex design. So if it were sealed, it might be a bit tighter, but with bass reflex, to get the output, you also have to deal with the fact that it kind of has extra ringing, essentially. And there are tricks, of course, processing and otherwise, to try to tighten that up and get it to sound more accurate, but that's just kind of the nature of these enclosures. Here's 80 Hertz, and you can see that it's a lot tighter. So here's the L18 at 30 Hertz. And at 80 Hertz. Now, I should probably say a couple of things about the physicality of these two cabinets. Obviously, they are about the same size, but the S118 is almost 200 pounds, and it does have the integrated STM flyware, which is really cool, whereas the L18 has no flyware, but it is very light, very easy to move around. I think it's just over 100 pounds or something. Well, today's been a very long, fun day of testing. I hope that you learned a lot about these particular cabinets, and hopefully you get to hear them in person someday if you haven't. Check out our YouTube channel for a bunch of other cool free content like this. See you next time.